Good morning. My name is Joshua. Uh, Today I'm going to be taking you through better investment in the stock market with AI prediction. Um, Basically, this is what we're going to be talking about. We're going to talk about the problem, the data set to be used in the AI solution, factors considered in picking our data set, and um, you can see what follows. Then onto the problem. We know that as an investigator, I mean, as an investor in the stock market, one has to be able to know the right moment to invest, the right time. Thereby, they have to be able to predict a certain rise or fall in the stock market, thereby knowing the right time to invest. Uh, this will enable them gain profit rather than get losses. Therefore, we're trying to remove and eliminate the problem of gain in losses or no profit gain when investing in the stock market. Then for our dataset description, basically we have chosen a dataset which belongs to the Tesla stock market, which contains timestamps showing the days when transactions took place. It has the price at which the stock opens, the stock market opens. It has the highest price at which the stock market hits and has the minimum price. Then also it has the closing price. It has the adjunct price, whereby for the adjunct, uh, this is the final closing price during that day. But certain factors are applied, for example, the trade policies and all that. Then we have the volume of stock sold in a day. So basically how we shall use it, we shall use the method of linear regression, uh, and this will help us to achieve a pattern and find the pattern for the growing stock, thereby by plotting actually a graph which will help us be able to predict the future rise or fall in the price. The factors that we chose when we picking out this data set, we looked at the usability of the data set. Uh, we looked at the problem being solved. Then we looked at the type of the method. Usability, we're talking about how clean our data is, how good the quality is, how authentic, and how easily it can be used. The problem being solved, for example, yeah, we're looking at stock market. So you have to basically get data related to that. Then we have the type of method. For example, we're going to use linear regression. Therefore, the data we need has to be continuous data. Therefore, we need to get that data which is continuous. And all our data and all the properties required by this, our data set has them. Then the features of the data set to be used in the AI model, like I told you, we have the date recorded. This gives a timestamp of when the transactions were recorded. The open, it shows the price of the stock when the market opens. Then we have high, shows the maximum price that the stock hits. Then we have the low, it shows the minimum price that the stock also hits. Then adjunct close, the one I told you, it shows the modified closing price based on corporate actions. Then we have volume. The volume, it indicates the amount of stock sold during the day. Then I'll be talking about Bayesian theorem, naive Bayes, and Bayesian networks. Basically, Bayesian theorem, uh, it's it comes from Bayes. It's also known as Bayes theorem. Uh, it's a probability, conditional probability that allows us basically get probability of, let me say, A given B, uh, supposing we know B given A. So basically, it's also used for implementation in machine learning. And basically, that is much about Bayesian theorem. Basically, it's given by that formula, probability of A given B is equals to probability of A intersection B over probability of B. So uh, the probability of A intersection B comes from the fact that if we're to interchange them, we can have probability of A intersection B being the same as probability of B intersection A. Therefore, we can come up with probability of the probability of A times probability of B given A. And that's how the formula comes about. Then for naive Bayes, um, this technique basically uh, deals with an assumption of showing the independence between, let me say, classes that is in the machine learning or AI. It basically says that something is independent rather than being dependent. For example, I can give an instance in spam detection whereby mm, we are basing on, let me say, like what for example, the message is a spam given that it has the words money and uh, hello. Uh, if the words are joined, for example, we can say hello money. Uh, Naive Bayes ignores that the fact that it ignores the fact that the words are joined together. And for example, if I interchange money and I put I put money first, then I put uh, hello next, it won't mind them. It will treat them the same way. That is why it's called as naive Bayes. It takes them independently. Then for Bayesian networks, basically I can say it's a joint probability distribution. It's it shows that it's represented by like a graphical model, basically throughout the whole system, uh, not let me say a particular class. It represents the whole system, the whole model. Um, then what is it? Bayesian networks, they're helpful in AI for solving probabilistic problems since they are probabilistic in nature. They can also be used for predicting events and derive relationships between multiple events. Then the difference between Bayesian theorem and naive Bayes assumes conditional independence, like I told you, uh, whereas Bayes theorem does not. Then for the difference between naive Bayes and Bayesian network, the Bayesian network shows joint probability distribution of events represented throughout the whole model. As for naive Bayes, it just shows uh, it's a simple model that describes a particular class in the Bayesian network, but not the whole network, a particular class. Then these are some of the references we used. I'd like to end there for now. Thank you for listening.